In this video, we will consider capacitors connected parallel to each other in a circuit. Throughout, remember that by the definition of capacitance, it is the proportionality constant between the charge separation and voltage. Previously, we have derived capacitance through separation of charges alongside parallel plates due to a potential difference provided by a source of electromotive force, for example, a battery. Now, we will consider multiple capacitors connected in parallel. Parallel in this context means that the path in between elements is not interrupted. Interruption can be by capacitors, resistive elements, sources of electromotive force, or any other devices that change the flow of the current by inducing a change in potential. Due to the conservation of charge, which states that charges may be separated but neither created nor destroyed, the total charge flowing into this parallel system must equal the total charge flowing out. Whether we have equal capacitors or different ones, the sum of the charges built upon them must equal the charge separation of the circuit as a whole. Note that even if the capacitors are different, the potential drop between the two paths connecting them in parallel must be the same. We will now derive an expression for equivalent capacitance, which is the mathematical equivalent of treating multiple capacitors together as if they were a single circuit item. For the purposes of this derivation, we will shorthand voltage across the elements as V, but keep in mind it actually stands for potential drop, usually denoted by delta V. Let's substitute in the definition of capacitance into our equation of conservation of charge. Now remember that the potential, and hence potential drop, for capacitors connected parallel to each other is the same. Factoring this out, we find that the expression for equivalent capacitance for parallel capacitors is just the sum of their respective capacitance. Please note that this is true for parallel circuits. The expression for series circuits is derived in a different video.